let's start. I forgot to move this back a little bit. Let's start with rectangles on page 4. Okay, now quick review as we talked about yesterday. I'm going to just give you some of these properties, right? Like say, hey, tell me the properties of a parallelogram. Well, definition of a parallelogram. Opposite sides parallel. Then I'm going to say, tell me some properties of parallelogram. Opposite sides congruent. Consecutive angles supplementary. Diagonals bisect. A rectangle, I should go with my diagram first. A rectangle is underneath the parallelogram. It has all the properties of a parallelogram. Okay? All of those are still true. There are a couple additional ones. The first one is just the basic rectangle definition. It's a parallelogram. Right? We already know that's type of parallelogram. That's in the folder right there. With 4 right angles. That's the basic definition. From the tab on the left. 4 right angles. We're not going to have time for these. Another way of saying that is 4 congruent angles. But if they're congruent, and it's going to be 360 degrees in quadrilateral, so they're all going to be right angles. Okay, now there's only one new property. There's parallelograms, all those properties, 4 right angles by definition, and then here's the new property or theorem: the diagonals are congruent. This is the one I discussed, I think 2 days ago, with parallelograms. Here, that diagonals only cut each other in half. They bisect. But they're not, the entire length of this diagonal is certainly not the same length as this one. But as soon as you make it perpendicular, now these lengths will be the same. And actually makes all 4 of these inside be the same because they were bisected. But if the actual lengths are all the same, then all 4 of the parts will be. Okay, I'm not going to have time for this one, so you can see my notes online if you want. You can try it. I think we'll be good moving on without it. Let's go on to the proof. There's one proof. This is one of the state standards. It's on the back board there. State standards show that the rectangle diagonals are congruent. What happened there? Let's see. So I'm going to draw on the. I have a rectangle ABC. Yes, rectangle ABCD. There's the diagonals. I'm going to show they're congruent. I am just going to do a 2-column proof. I'll throw in a flow chart here soon, but let's do a 2-column proof today. Question came up earlier. Can you make a symbol for rectangle? I just abbreviate it RECT. I think that's shorter. If you do this and put 4 right angles in, that's fine if you want to abbreviate as a symbol.
Isn't that a square as well?
No, square would have congruent sides as well. So I guess the symbol for square would be this and the right angles. Good question. I think it's just shorter. You would just write RECT, rectangle. Or just write out the entire word. Let's see what else. Diagonals, AC and BP. Okay. Again, the goal is going to be showing 2 triangles are congruent, and we got to decide which triangles. Yeah, thank you. Let's see, okay, so showing triangles are congruent. Which ones? That's the past few proofs we've done, it's kind of deciding which triangles. Sometimes they'll tell you, sometimes not. This one, when I was think about it, let's say I did the same 2 as yesterday. Didn't I do I think I did the top and bottom ones, small ones? I could try and do those. It would work. It's going to be a lot longer proof, though, because then, even if I get those congruent, I would only be able to show that these parts are congruent. Then I'd do segment addition. Then I'd have to say because these are equal, then this plus this, and It's like twice as long. Maybe not twice as long, but there's several more steps. That would work though. I could do diagonals bisected and then vertical angles and get SAS. Okay. It's a lot longer though than what I'm going to do. What I'm going to do is the standard way to show the rectangles that are congruent. The standard way is to just choose triangles that have this length and this length as part of the sides of the triangle. So then once I show the triangles are congruent, I'm done. Like these will be as well. So let's choose two triangles that have those side lengths. There's several you can choose, several pairs. I'm going to choose this one, ACD, and this one, BCD. So if I show those two triangles are congruent, then AC and BD will be, because they're just the hypotenuse of those triangles. And yes, hypotenuse. That's correct. Okay, so I'm going to show those two triangles are congruent. If you'd like, these are overlapping triangles, and when we did these in class in our congruent triangle unit, you could redraw them. So if you'd like, I sometimes do this, like draw them as separate. So I'll do both. Yes.
Would we be allowed to use groups earlier from like parallelograms, since rectangles are parallelograms? So
yes, and we're going to on this one. And if it was a quiz or test, I would tell you yes or no, you can or cannot use the properties.
Got it. Thanks.
Yeah. But on this one, I left it blank so I could discuss that we are going to use one of the parallelogram properties. So let's go ahead and do that one. Since it's a parallelogram, the one property we're going to need to use is that the opposite sides are congruent. So that is a parallelogram. So I can say AD congruent to BC. I just write it out in words what that property is. Opposite sides of a parallelogram are congruent. Let's see, what else? Let's get another side. So I'm not going to get the hypotenuse, but you guys see down here is the reason these two sides will be congruent?
Flex it.
Between the triangles, well, it's DC in the one triangle, and it's CD or DC in another triangle. It's the same side. They share a side, thank you. So let's do that one. Is DC to CD? I think this one makes sense because what's going to be D down here is going to be a right angle. And so I have to match up the right angle in the red triangle, D, with the right angle in the blue triangle, which is C. So it's D to C and C to D. That's reflexive property. I'm down to needing one more angle or one more side. And I'm not going to get the side because that's what we're trying to prove. So once we have the triangles congruent, we'll get the hypotenuse. We need one more angle. And I go back to the fact that it's a rectangle. The basic definition of a rectangle is that these are right angles. I could name all four of the right angles in the parallelogram. I'm sorry, in the rectangle. I can name all four of them if I want, but I only need these two. Alright, so angle, let's see, ADC and angle BCD. That says angle BCD are right angles. That is just because it's a rectangle. Definition of rectangle. Four right angles. I then need to we've got to kind of use this two-step process. I need to say that they're right angles, then say they're congruent. So angle ADC is congruent to angle BCD. All right angles are congruent. Yes, Trent?
Wait. Never mind.
And most of those steps 2 through 5 can be in any order. I could have done rectangles, make right angles, and then step 5, that's 3. They're congruent. And then I could have said the sides from steps 2. So I got enough. In each of the triangles, I have 2 sides and the included angle. 2 sides and included angle. So the triangles will be congruent by SAS. Triangle ABC congruent to triangle BC. And then the hypotenuse, the diagonals. AC is congruent to BD. CPCTC. That is an important one to know. Most of the other standards proof ones are parallelograms. This is really the only rectangle, a non-parallelogram one. There's others, but this is the only non-parallelogram one from the state standards. Anything to answer about rectangles? So basically 2 things to know for rectangle. One is that it has right angles, by definition. The only other property is the diagonals are congruent. And know how to prove that. Okay, so that's the only new thing for rectangles. Did you know, fun fact for the day, that a rectangle, Ohio is the only state flag that is not a rectangle. Did you know that?
It has stars.
Does it? You're in the star kit. Yes, it has decagons. Is that what you're saying? Decagons, decagons, decagons.
That's what I said. I said decagons.
She asked me about stars earlier. I said they're decagons.
The other day, it was 5 minutes ago.
There. That didn't work out as well as I wanted.
That's a glove.
Well,
That's a leprechaun.
I would say this looks like a bird. Do you think this looks like a bird?
Yeah, it does look like a bird.
Like a bird face or something?
Oh, it's like a
Oh,
very
stars.
Like there's the
Wait,
beak.
did you just draw his body? Is that his body?
Yeah. Moving on. Okay, so that's it for rectangles. Let's move on to rhombi. Here's my rhombi word cloud. I have several. Here's where it says that is the pronunciation or the plural of the word rhombus. Rhombi. Right there. So it is a fact.
Spinning. Spinning reference.
This is the
Greek.
European word for rhombi.
Oh, so.
Why does it say spinning? It doesn't say meaning.
You can rotate a rhombus 180 and it's maybe.
What do they mean by meaning?
Guys, I didn't make this, okay? So by a pyramid. What's it by?
Is Rainbow
Rambo, it's like Rambo. You seen Rambo the movie?
References.
Okay. Moving on. So I'm just thinking about rhombi, and then you're like, well, what about squares? Well, rhombi, let's go back to the diagram. A square is just a rectangle and a rhombi together. There are no new properties with the square. So once you have all the rectangle properties and the rhombi properties, then that's a square if you have them both together. A square is really just the basic definition. 4 congruent sides and 4 right angles. So let's look at rhombi. This is a type of parallelogram. It has all the properties of a parallelogram. It does not have the properties of a rectangle. Did you have a question for that? No. It is a parallelogram with 4 congruent sides. That's the basic definition. 4 congruent sides. There are 2 new properties. So let me go on this list here. All the properties of parallelogram, that's old. Definition, 4 congruent sides, first older. Yeah, I forgot about that. By definition, 4 congruent sides. Now there's 2 new properties. First one is when you have the diagonals drawn in, they are perpendicular. So I know this one isn't to scale, but by definition, 4 congruent sides. If I draw in the diagonals, then they are perpendicular. So they make 4 right angles. Then the other property is each diagonal of a rhombus is an angle bisector. So the diagonals are angle bisectors. So let me show you on the diagram, like DB is bisecting this angle, cutting it in half. Now up here, still on DB, but at this angle, I would normally say, all right, well, it's bisecting, so it makes different angle measures here. However, this angle and this angle are alternate interior. And since it's a parallelogram, has parallel sides, they'll actually be the same. So actually, all four of these angles are the same measure that I marked. And then for the other diagonal, it bisects that angle, and then all of these are the same as these two. So that's the diagram for a rhombus. And what you'll know, which we're going to use in this proof right here, each of these triangles is actually congruent. So when you draw the diagonals, this is another, I'm going to write it down. It's not like an actual technical theorem, but it is true that the diagonals make four congruent triangles. Yeah. And they make four congruent right triangles. So then you can do like Pythagorean theorem.
Oh yeah, they do.
Pythagorean theorem, special right triangles. Yeah. I agree. Crazy, like crazy awesome. Right?
Crazy awesome.
Okay, let's do, I want to do one proof with this, and then I'm basically going to sum up. I'm not going to do this one example. I'm just going to say what a square is to finish up. So let's set up this proof. What I'm going to do is I'm going to have A, B, C, D a parallelogram. I'm going to give you that the diagonals are perpendicular, and I want to show it's a rhombus. So I know we talked about the properties. If it's a rhombus, yeah, these properties are true. But we're going to show it's a rhombus. Okay, so setting it up here. Provided ABCD is a parallelogram, and the diagonals AC and BD are perpendicular. Let me draw in the diagonals. So we do not know that they are, we do know it's perpendicular. We don't know it's a rhombus yet. We're trying to show a rhombus. To show a rhombus, whenever you're trying to show it's a figure, the best approach is to get the basic definition of that figure. So for a parallelogram, we show opposite sides parallel. For a rhombus, we're going to show four congruent sides. That's the basic definition. The sides, A, B, B, C, C, D, and D, A, will be congruent if the triangles are. So to attack this question, now there are different approaches to this. There are different ways to do this. So I'm only doing one method for this proof. I'm going to show the four triangles are congruent, and then all the four sides will be. Okay, but there are different approaches for this. Yes?
Couldn't you just say, since we can still use the theorems from earlier, couldn't you just say BC equals AD, AB equals CD because of
Yes.
the parallelogram theorem?
Yes, but that would only get opposite ones. We need all four congruent. So then we'd have to do something with adjacent triangles.
Oh.
So you're right. He said the opposite ones, it's a parallelogram. So yes, that's true. The opposite ones are congruent. But we're going to need more than that. We're trying to show all four sides are congruent.
Got it.
Yeah.
Okay.
So you're right. That's a good approach. And you know what? What I was planning on doing? I have to get some angles, and I would still need another side in the triangles. So I'm not even going to do this. I could do that property, but I'm not going to because I'd still need other things. All right, so here we go. I'm going to just get the four right angles in the middle first. It's given that they're perpendicular, so these are right angles. Hey guys, to make it shorter here, just we're a little short on time, class periods today. I'm going to call angles 1, 2, 3, and 4. So angle 1, 2, 3, and 4 are right angles. Rather than naming it A, E, B, and C, E, B, just take a while. definition of perpendicular? Perpendicular means forms right angles. Now, just like we did in the last one, we'll just say they're congruent. I'm going to say all four are congruent at once, right? Just an extended congruency statement. 1 congruent to 2, congruent to 3, congruent to angle 4. And as again, all right angles are congruent. Again, I'm going for the 4 little triangles on the inside, congruent, because then all the sides, the rhombus sides will be the hypotenuse. I've got one angle. I need some other sides. I'm not going to be getting the outside ones. I could get the opposite, but not all of them. So I'm going to attack and get the little segments here, here and here congruent. It's a parallelogram. And in a parallelogram, yeah, diagonals bisect. Diagonals bisect each other. So these two are congruent and these two. I am going to need to call that interior point E, like we did yesterday. Interior one. So now I need to name the segments. Okay, so I'm going to name it, let's see, B, E, and D, E. Those are congruent. And then the other two segments, A, E, and C. That was because of the property that diagonals bisect each other. So I have to name the parallelogram property. So I'm going to say I'll say diagonals bisect each other. In a parallelogram. Now, technically, I also use the bisect definition. So if it's already there, I'm just going to put slash definition of segment bisector. I kind of did 2 in 1 there. It's like it's the property I was using, but then the definition of bisect says the segments are congruent. Okay, and that's really the hardest part, is just getting all that, knowing which triangles, right angles, and then the bisect. Guys, because now, let's see if I can get a different color here. Now all 4 triangles are congruent. If I look at one of those, I have a right angle, and then I have 1 slash mark and 2 for 2 sides congruent. You need somebody?
I don't know, is that Athena?
She's over
Hi.
There she is.
Need her for a minute?
Just 5 seconds. Thank you. Sorry to interrupt.
I heard my name.
So do you see that? There's 1 segment, 2 segments, and an angle included. Same in every triangle. 1, 2, and an angle. 1, 2 in the right angle. 1, 2 in the right angle. So all 4 triangles are congruent. I'm going to name all 4 triangles. A triangle, and just all together. All 4 are congruent. This step, triangle ABE, top left one. Congruent to triangle, top one, BCE. There's also different ways to name these. I'm just this order. Next triangle, DCE. Congruent to triangle, DAE. So I just put them all where the last part was E, the last point. They're all congruent because they have 2 sides and the included right angle. So that is SAS. All right, and to finish up, then the segments on the outside of the rhombus there, well, parallelogram for now, are congruent because they're the hypotenusa of the 4 inside right triangles. So triangles are congruent, so therefore the segments are AB and BC congruent to CD and DA. So it's all 4 of the segments on the outside. CP, CTC. One last step. If all the segments on the outside are congruent, then we can name it as a rhombus. See, the final step should say ABCD is a rhombus. So if all four segments, yep, that's a rhombus. So I'll put A, B, C, D as a rhombus. Okay, and that is just the definition. Definition of a rhombus is it has four congruent sides. Oh wow. I didn't realize I was short. Hey, last thing I need to say to finish up, I didn't realize I was at the end here. Hold up, let's write this down. A square is four right angles and four congruent sides. I talked about it a few minutes ago. In other words, it's a rectangle and a rhombus together. You can see the pictures at the bottom. Hey, I should say this to finish up. It has four 45, 45, 90 triangles.